Hey everybody, and welcome to the wonderful world of radical expression, addition, and subtraction with Mrs. C. So listen guys, we've been doing this in class now for a couple days. We learned how to simplify radicals, and now we're just working with them and trying to do operations with them, mainly adding and subtracting at this point. But what that requires us to do is to notice that these radicals are not the same. We have a root 2, a root 20, and a root 8. And as we talked about in class, you can't combine radicals that are not exactly the same, just like you can't combine radicals that, variables that are not the same. For example, if this had been a negative 3x, let's say that root 2 is equal to x. And let's just say, for argument, that the square root of 20 is equal to y. And then we'll just go full out, and we'll just presume that the square root of 8 is equal to z. So what we would see is we really have three different variables, don't we? So in the first case, we have a negative 3x, because x is equal to root 2. Then we have a positive 3. What would root 20 be? Y. Yep. And you probably see where I'm going with this. We have a negative 3z, because the square root of 8, just for discussion's sake, it would be equal to the square root of 8. So we can't combine through the rules of addition and subtraction a 3x, a 3y, and a 3z. We have to put them in the same term, which means these things would have to match, and they don't. And that's why we've learned how to simplify, honestly, because if we can make them match, then we can combine them. And it's really kind of cool, I gotta say. It's like a little puzzle here. So oftentimes one thing I'll do when I start is I'll see if I can identify where anybody is already in simplest terms. And you probably see this, I'm sure you recognize it at this point. Negative 3 root 2. Root 2 is a simplified radical. So we've already had our general lesson and intuition on radicals. So if you don't identify that root 2 is simplified, you might want to go back to one of the simplifying radical videos. So I'm just moving that one over, cross it out because I don't want to get confused with it. I already rewrote it. So let's take a look at root 20. Now, picture them separate. The 3's on the outside and root 20's on the other side, because I don't want to get confused when I break root 20 down and start renaming it in its factors, and the factors that would multiply to give me 20. Those would also be the roots that would multiply to give me root 20. So we think about 20, and we try to ask ourselves, what perfect square factor does 20 have? And let's just list them real quick off to the side. The perfect square factors: 1, 4, 9, 16. And if you're wondering where they're coming from, I'm asking myself here, got too close to the edge. On this one, I'm asking, what was 1 squared? What was 2 squared? What is 3 squared? What is 4 squared? And so on, right? 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. And I would continue: 121, 144, 169. But I ran out of room on my page, so I'm going to stop there. And those are usually enough to get you going. And you go back to the square root of 20. I'm over here again. And you ask yourself, oh, do I have any factors of 20 that are perfect squares? And yes, 4. 4's on my list. So then I just follow up with, well, 4 times what? 4 times 5. You might be saying, well, 5's not on my list. That's okay. You really only need 1. If you had 2, you would have had a perfect square to begin with. So don't worry about that. So the square root of 4 times the square root of 5 is the square root of 20. And so which of those was perfect? It was the square root of 4. What's the square root of 4? 2. So we just write a 2. Now, When you actually find the square root of a number, I'm going to ask you not to write it where I just wrote it, but write it over on this side, because any number that comes out of the radical, because it's a perfect square, is going to times to any other number that comes out or is already out. So that 3 on the left side and that 2 are going to come together to become 6. And it's going to leave root 5. All right, so all of that work gives me 6 root 5. And I'm going to just erase this because I want to 6 root 5, 6 root 5, 6 root 5, 6 root 5. I don't want to forget. All right, 6 root 5. I am going to just bring down negative 3 root 2 because now I have my list over on the right side. It's going to get confusing to me. All right, we've got a 3 root 8. So let me just do this. I want to simplify root 8 into factors. It doesn't have to be 2. I almost said 2 factors. It really doesn't. It's as many factors as you want. But again, you're looking over at this list and you're asking yourself, are any of the factors of 8 in my list of perfect square factors? Yes, it's 4 again. 4 is a popular one. The square root of 4 times the square root of 2 would be the square root of 8. The square root of 4 is 2. That 2 comes over here and times to the number, multiplies to the number that's on there, already out there, negative 3. So those two would times together. They would give me negative 6, and I would bring down the root 2. So now I have a negative 6 root 2. All right, I think I got it here. I'm changing my pen. Negative 6 root 2. Now is the fun part. All this work pays off at this point because we look to see, do I have any terms that are alike? Do I have any radicals that are alike so that I could use the rules of addition and subtraction to combine them? Here they are, 3 root 2 and a 6 root 2. Now, if I have a negative 3 root 2's and I combine that with another negative 6 root 2's, how many root 2's do I have? Well, I have negative 3 and negative 6 is a negative 9. And how many of them I have? Root 2's. I have negative 9 root 2's. Now, I simplified those two by combining them to be negative 9 root 2. I'm just going to bring down this 6 root 5, but I have to ask myself, what the heck is the sign? I never put it down. It's right there. I should have written positive. So plus 6 root 5. Final answer. I like to put the negative in the back, but I don't want to rewrite that. So for now, we'll go with negative 9 root 2 plus 6 root 5, or option 6 root 5 minus 9 root 2. Okay, well that's a lot, isn't it? Let me erase that and just clear my board a little bit here. I don't know if I can. Yes, I can. I'm going to move this up a little so we have more room. I know I did chop off my list over there. All right, well, we're just going to have to go with it because I would rather have more space. I want you to visualize, and in fact, you should just copy that list yourself. Make your own little list of perfect square factors. It's always good to have. All right, here we are. Negative 2 root 20. I have a root 20, a root 18, and a root 5. None of them are the same. So let me start getting down to business. Separate. Break them down. 4 and 5. We did a 20 already, so this should just be review. Square root of 4 is 2. Negative 2 times 2 is a negative 4. The square root of 5. That's that one. Let's break the next one down. 18. Let's think of 18. Well, 6 times 3 is 18, but neither of those factors is on my list, so I don't like that. 18 times 1, nope, that won't work either. 9 times 2, bingo. 9 and 2. The square root of 9 times the square root of 2 is the square root of 18. The square root of 9 is 3. So 2 times 3 is 6, and root 2 is left. Look at the sign up at the top. It was a positive. put that in between. Coming down to the last little term. I'm sorry, going to have to erase that because I'm out of room. All right. Nope, don't write it. Don't do it. Sorry. Oop, hang on. Hold, please. Okay. Here we are. Square root of 5. Okay, break down square root of 5. Well, 5 is prime. So 5 times 1 is all I can do. When your factors are prime, or prime and unique in this case because your number is prime, then there's nothing you can do. That's when you know you're done. When none of your factors have perfect square factors, or excuse me, rewind, playback. When none of the factors of your number or of your root are perfect square factors, then there's nothing you can do, which, hey, rock on. You can't do anything. I just copy it. And then I search. I look to see if there is a situation where I can combine, and here you see it. Hopefully you see it. Root 5s. Negative 4 root 5s and a negative 2 root 5 would give me, you know what it is, I hope, would give me a negative 6 root 5. So I'm out of space there. I'm going to write it up at the top. Negative 6 root 5. And who was left? 6 root 2 plus 6 root 2. And I had said before, I like to put the negative in the back. So if I go down to the bottom of the page, just to show you, I like to write 6 root 2 minus 6 root 5. Because I like my minus sign in the middle and not sticking out in front where somebody's going to lose it or make, I don't know, get confused with it, or it looks tacky. Come on, just face it. It just doesn't look right. All right. Who cares what it looks like? The answer's right. All right, I'm going to move us up just a little bit more, and we're going to do number 25. And again, a good thing for you guys to do when I'm doing this is for you to do the problem on your own and pause me, and then come back and follow the process and see if you did it right. Now, I want to take a look at this because it's overwhelming if you look at it, but if you look a little bit closer, you're going to see this is a nice problem. This problem is actually easier than the others. 2 root 5 is simplified, and 2 root 6, I know 6 doesn't appear simple, but if you factored 6, you'd get 6 and 1 or 2 and 3. Those are prime factors, 2 and 3. There's no perfect square factor within the factors of 6, and so 6 is a simplified root if it's radical 6. So I love radical 6 because I know that there's nothing I can do to it. So in most cases, I'm really excited when I see radical 6. But you do have to recognize it because it just has a little look about it because it's even. Makes you think that there's something you can do. So these two guys are good. Nothing I can do with them. So they're just going to hang out while I do the rest. So we've got, what's on the left side? It's a negative, but what's the value? It'd be a negative 1, right? So just so you know, I mean, it's good to realize that it's a negative 1. Square root of 45. So you run through the square roots of 45 in your head, right? The one that pops into my mind is 9 and 5. And that actually, I believe, is going to be the deal. So sometimes you get lucky and you think of your perfect square factor right off the bat. 9 times 5 is 45. Square root of 9 is 3. 3 times multiplies to negative 1, and you get a negative 3 root 5. All right, coming on over to this guy. Oh, no, not that guy. Just said I didn't have anything to do to that guy. All right, again, negative root 20 means a negative 1 root 20. Breaking down 20, we've done this before. This is our third time breaking down 20. Square root of 4 times the square root of 5. And square root of 4 is 2. 2 times a negative 1 is a negative 2. And keep that negative 5. So I'd like to circle the players in the game at this point because it does look a little messy. There's this one. There's this one. There's this one. And there's this one. You don't want to lose any roots. I'm going to write my answer above because it's just no room at the bottom. And let's take a look. I think, because I like to put my negative last, and I know these bottom guys are going to give me, well, look at all the root 5s. Oh my gosh. I just realized I don't know why I was assuming I would have 2 root 6s and 2 root 5s. I don't. I have 3 root 5s. Oh, that's so awesome. That's fun. I don't know that I've ever done one of these with you guys. So let's go. I can't even wait. We've got the negative root 5 right here, the positive 2 root 5, and the negative 2 root 5. And I'm sorry, this was negative 3 root 5. I was so excited I forgot. Put the negatives together because I like to add as much as I can. So negative 3 and a negative 2 is a negative 5, root 5. But then I have the positive 2 up there. So that's going to be a negative 3. What did I do in my head? I know they're root 5s, so just write it. So I'm combining a negative 3 plus, minus a 2 and plus a 2. That's what I did in my head. Wouldn't it have been easier in my head to just say those cancel out and voila, negative 3 is left? Yeah, that would have been a lot easier. I didn't do it that way though. So, oh well. Negative 3, root 5, that's that one done, that one done, that one done. I don't have to do anything with this one. Negative 2, root 6, final answer. I can't hide the negative. They both have negatives. And that's the answer. I love it. Oh my gosh, that was so much fun, wasn't it? Who deserves to have this much fun doing math? I don't know. All right, guys, come on over to the next page. And I don't know why that got bigger, but it did. This is what I think you should do. Practice these problems, right? And what I'll do for you is I'm just going to post the answers in the process. So what you want to do is pause me because I'm not going to give you the instruction on this. I'm just going to give you the answers and say a fond farewell in a moment, and then we'll be done because it's almost time for me to go to work and I got to get going. So pause for a moment while I do the math too. You do the math. We'll come back together and we'll see how it goes. All right, well, I couldn't fit all of them on there, so I just want to show you what I've got so far, and I'm going to have to pause it again. So for 24, my final answer was 12 root 2 minus 4 root 3. You can take a look at the process right there. 2 of them became root 2's, and one of them was a root 3. So you combine the root 2's, 6 root 2, 6 root 2 is 12 root 2, and that leaves you the negative 4 root 3. You are going to notice that when I have squeezed process in here, very hard for me to write with the stylus on the size board. I am dropping the little radical that I usually show over here under the root 9 and root 2. I just don't have the room to do it. Please don't do that when you're doing your process. That radical is really important for you when you're learning. Not so much when you're a little bit older and you know what you're doing, but when you're just learning to see the radical, to know that number is within a radical and not outside of the radical, really kind of important. So you continue to do that. 26 was like awesomely cool. You knew root 20s were going to be the same, but did you know root 45 was going to be the same simplified root as radical 20? I mean, who saw that coming? They were all radical 5s. They were all root 5s, and they all came together to be a little negative root 5, which I thought was really quite cool. And then coming down to the last one, didn't have time to do it, and I'm out of time, so I want you to go ahead and do 28, and in fact, do more than 28, because these problems came off of the Kuta software site. Love Kuta software. Shout out to you guys, because you make algebra so easy to practice with your free worksheets. So go to Kuta software. If you go back again, you'll see 28 was the one that I didn't do. And in fact, check all my answers on Kuta. Send me a little blurb down at the bottom if I screwed anything up, please, so that I can fix it. And practice your radicals, because radicals equal awesomeness, absolute awesomeness. Love you guys. Have a great day. See you on the flip side.